Okay, now we're moving on to part C of this question, which is asking us to actually just evaluate the integral we calculated in the previous video. So this is the integral. So now let's actually evaluate it. If we're taking the integral of all the small dE's, then obviously we just get the entire electric field, right? And then I'm going to take the integral of this side as well. So K, Q, and L are all constants, so I can take it out of the integral. And just integrate dx over x plus a squared, because there's an x in this term. And now here's the tricky bit. We have to figure out the bounds for the integration. Well, oh crap. Well, if you look at this diagram, you see that it starts at negative L right here, and then it goes to 0, right? Dx always goes in the positive direction, so it starts at negative L and it goes to 0. And you know it starts at negative L instead of L, it's because L is positive 1.6, and we consider this to be in the negative direction. So this is going from negative L to 0. So I'm gonna actually solve the integral now. How I will solve it is actually using u substitution. So I'll say u is equal to x plus a. So that means du is equal to du is equal to, sorry, this is not x plus a. I made a mistake in the last video. If you remember, this is actually the term that should be at the bottom, a minus x. So this should be a minus x instead of x plus a. So this is a minus x. So this is negative dx. And if we plug in u's, I'm not going to worry about the bounds for integration yet because I need to plug back in u. So this is du, negative du over u squared. And if we solve that one out, then it's equal to negative kq over L times, well, times negative u to negative 1. So these two guys cancel out. And then I'm just going to plug back in u is equal to a minus x, so this is times a minus x divided by negative 1, and then the bounds of integration is from negative L to 0. So finally now I'm gonna plug it in. So this is still kq over L, and then I'm gonna first plug in 0, right? So 1 over a minus 0, that's just a, minus 1 over a minus negative L, so that's just a plus L, right? And if we want to simplify this down, we find the common denominator, which is going to be a times a plus L, so this is kq over L times a plus L over a times a plus L, right? This thing minus a, right? So then the two a's cancel out, and then we're left with this equation actually can be simplified a little bit further, because once two a's cancel, you also can cancel out these two l's. So then your final equation for the electric field is kq over a times a plus L. Check if that's correct. Yep, that is correct.